Good morning, this is Ms. Billerbeck, and we're going to talk about 7.4 properties of polygons. All right, let me share the screen and we'll talk about some qualities of polygons. All right, so properties of polygons. So you're going to be able to name polygons, classify polygons based on concave or convex, if they're equilateral, equiangular, or regular, and calculate and use measures of interior and exterior angles of polygons. So a polygon, so we have different types of polygons. So a closed plane figure formed by three or more non-collinear. Non-collinear means means works together, linear means line. So works together to make a line, and non means not. So it's not working together to make a line. So non-collinear means that these are lines that are not making one solid line that goes on forever, like these little blue lines in the background. All right, so so they intersect only at their endpoints here. So we don't have any intersecting lines going on. So polygons look like this. But this is not a polygon because it intersects like this, not at an endpoint. This is not a polygon because it's got an arc here. It's not a straight line intersecting at an endpoint. It is a curved line, so that makes it not a polygon. Okay, common endpoint of two sides is called a vertex. So we have a vertex here where the two lines intersect. A diagonal, which you've learned from the last lesson, connects a vertex to another vertex, but it lies on the interior of the polygon. So a regular polygon is both equilateral and equiangular. So that means all the sides are equal and all the interior angles and exterior angles, all the interior angles are equal with themselves, and all the exterior angles on the outside are going to be equal with themselves, with each other. Okay, so polygons are named by the number of their sides. So tricycle, so but three angles, triangle. 4 is quadrilateral, and lateral means side, so 4 sides. 5 is pentagon is angle, so 5 angles. 6 hexa, and then gon, so 6 angles. 7 hepta or septa is another name, septagon or heptagon. That means 7 angles, so heptagon. Octagon is 8, like octopus has 8 legs. Octagon, 8 angles. 9, nonagon. Okay, so that sounds kind of similar to 9. 10, deca. So deca means 10. You'll hear that a lot in the metric system. So 10 angles. Here's a cool one, dodecagon for 12. And then if there's n here, it's just n-gon. Okay, so it's an n-gon. That's a type of polygon where we don't know how many sides it has. Okay, so we want to name a few of these. This has got 1, 2, 3, 4, 5. So it's a pentagon, like the Pentagon in Washington. Here's a dodecagon. Okay, so that means 12. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. And a quadrilateral means 4 sides. 1, 2, 3, 4. Okay, so concave. A diagonal of a polygon contains points outside the polygon or caved in. Okay. So mainly if you can have a little caveman hang out in a cave like this, then it's concave. Okay, So convex means there's no caves for the little caveman to hang out in, okay? So we have concave, meaning there is a cave, with cave. Convex means no cave. So remember, con means with, so with cave. All right. We know that angles of triangles add up to 180, but what about other polygons? So we want to draw a convex polygon of at least 4 sides. So we have a pentagon here, and if we draw diagonals from one vertex like this, we have now 3 triangles inside. So these angles add up to 180, these add up to 180, and these add up to 180. So if we add all of these together, we end up getting 540 degrees. So the interior angle sum of a pentagon is 540 degrees. So the Polygon Angle Sum theorem says that the interior angles of a convex polygon, so it can't be concave, but convex polygon with insides, is n minus 2 times 180. So if the polygon is equal angular, so that means all the angles are the same measure on the inside, then the measure of one angle can be found by n minus 2. The number of sides is n. So number of sides minus 2 times 180 divided by n. So if you're wondering, what is this n minus 2? So remember, this is a pentagon. 1, 2, 3, 4, 5 sides, but there's only 3 triangles. So we subtract 2. So 5 minus 2 gives us 3. And then if we multiply 3 times 180, we got 540. So that's where that n minus 2 is coming from, right here. And then individual angles, again, you divide by 5 on that pentagon, and then you would find your individual angles since they're equal. So if we see that with a triangle, we have 180, so the interior angle sum's 180. And if it's a regular triangle, each angle would then have to be 60, because 180 divided by 3 is 60. A quadrilateral would have 2 triangles in it. If you drew one diagonal across, you'd have 2 times 180, which is 360. And if you divide that by 4 sides, that gives you each angle is 90 degrees. We already looked at the pentagon, so there were 3 triangles in it. So 3 times 180, and that's 540. You divide 540 by 5, and you get 108. So let's look at some of these other figures. So a hexagon has 4 triangles. So it would have 720, and divide that by 6, and you get 120 for each angle, only if the hexagon was a regular hexagon. I mean, all the sides were the same, meaning all the angles, interior angles, were the same. And this goes through how you would find each of them. So in the end, we see, okay, so this is an octagon. There's 6 triangles, but there's 8 sides. So that's where n minus 2 comes from. So if I subtract 2 from 9, I get 7 triangles times 180 to get my interior angle sum. So that's where this formula is. So n minus 2 times 180. And then if we have a regular n polygon or n-gon, we would find the individual interior angle would be n minus 2 times 180 divided by n. So if we look at exterior angles, we already talked about the exterior angle theorem for a triangle, how this angle is equal to the sum of the non-adjacent angles here. Okay, but if we consider a polygon with more sides than 3, these are our exterior angles right here. Okay, so this is for a regular pentagon. Okay, so if this interior angle was 108 and these form a linear pair, then that should add up to 180. So 180 minus 108 is 72. Okay, so if we have 5 of these angles and we multiply 5 times 72, we get 360 degrees. So the exterior angle sum is 60 degrees. Oops, sorry about that. The exterior angle sum is 360 degrees. Okay, so we have the Polygon exterior angle sum. The sum of the exterior angles of a complex polygon is 360 degrees. So if it's a regular polygon, we just divide 360 degrees by the number of sides to find the exterior angles, each exterior angle. So for a triangle, if it's an equilateral triangle, then the exterior angles, each exterior angle is 120. If it's a hexagon, each exterior angle would be 360 divided by 6 is 60. And this is a wonderful sum. So the formula ends up for the individual exterior angle of a regular polygon would be 360 divided by n. All right. So let's do some examples now. Okay, so we know that we're going to be using this formula for the interior angle sum, n minus 2 times 180. So if we look at this figure, it's a quadrilateral. So we have 4 minus 2 times 180, which is 2 times 180, which is basically 360 degrees. So the interior angle sum should equal that. And if we subtract 360 minus, and this little box here is 90 degrees, minus 75 degrees, minus 68 degrees. Okay, that's going to end up being y. Okay, so 360 minus 90 gives us 270. And 270 minus, and then we're going to subtract the 75 from that and the 68 degrees. So 270 minus 75 gives us 195 minus 68. And then when we subtract that, we get 7, and then that's at 27 degrees. Okay, so we double check, 68 plus 27 is 95. Oops, there's a 1 in front of that, so 127. Okay, so we have 127 here plus 68 gives us 195. And then that's, okay, so that should be good. So we have y equals 195 degrees. Oh, sorry. Is 127 degrees. There we go. All right, so we have find x, y, z. So we have all these. We have a hexagon here, and it looks like a regular hexagon to begin with. So that would mean that we have all our sides are congruent. And it also means all the interior angles are congruent. So we are going to take n minus 2 times 180, but it's a hexagon. So instead of n, we can write 6, because a hexagon has 6 sides, 1, 2, 3, 4, 5, 6. And we're going to divide it by 6 to find that x. Okay, the one angle right there. So that's x. All right, so we have 4 times 180 over 6. We can cancel out this and this to make that 30 degrees to make our calculation a little easier. So x is 120 degrees. All right, so then we need to figure out, well, what are these angles here? So we have y, and we see that this is halfway, so this is bisected here. So this is also y. Okay, so this is half the quadrilateral. This is equal and that's equal. So this half is equal to that. So if this and this added up should equal 120. So we have y plus y should equal 120. So 2y equals 120, and then we divide by 2, and we get y equals 60 degrees. All right, so now we have 60 degrees here. We need to figure out what this angle is here. So we know that these angles here and here are equal because it's an isosceles triangle. Okay, and once we have that, we know that this is 60 degrees, the whole thing, so we can subtract this angle from the 60 degrees to get y. So we have 180 equals the 120, which is x, minus, and we have 2a. We don't know what these mysterious angles are, but we're going to call them a. So we'll call that angle a right there. All right, subtract the 120 from both sides, and we get 60 equals 2a. That's a plus sign right there. When we divide by 2 on both sides, we get a equals 30 degrees. So that would mean that z ends up being 60 degrees minus 30 degrees, so z ends up 30 degrees. So our answers are right here. We're going to have to box them in because this got a little messy. And we ran out of room. So there's our little box. Okay. Okay, so this one says, find the sum of an n-sided polygon. So that the angle sum of the interior is 1620 degrees. So find n. So we have n minus 2 times 180 equals 1620 degrees. We know that this is an interior angle sum versus an exterior angle sum because all exterior angle sums add up to 360 degrees. So even though they forgot to say that in the instructions, we have to assume this is an interior angle sum. All right, so we're going to divide by 180 to get n minus 2 free. Okay, we can take the zeros out. And let's see if we can, let's see. So that cancels that out. So we have n minus 2 equals, and let's see, 18 into 162. Let's see what that is going to be. So let's see, it ends in 2, so let's go with 9. So 972, and there we have it. Okay, so we got it. So that's going to equal 9, and then we add 2 to both sides, and n equals 11. So this particular polygon has 11 sides. All right, so x and y, the sum of the exterior angles is 360, so we have to remember that. So if we're given this, we know x is a linear pair to 44, okay? So we can find x very quickly. So x equals 180 minus 44, because linear pairs are supplementary. They add up to 180. So that means that x would have to be less than 180. And let's see, we've got 6, and that's 36 degrees. So we check that 44 plus, oh, it's 136. There we go. So 44. So we add that, that's 140 plus 40 is 180. So we're good. All right. Then we know that these add up to 360. So y equals 360 minus 136 minus 111 degrees. So we can just use the dry erase calculator to do this. Okay, so we take one here. We have 4, 2, 2. So we have 224. So 224 minus 111, and we have 3, 1, 1. So y ends up 113 degrees. Okay, so they should all add up. When we add them together as a check, it should all add up to 360. So that's 10, 6, 3. So it checks. Okay, so this one says find the measure of each interior and exterior angle of a regular octagon. Okay, regular means all the sides and angles are interior angles are congruent, and there are 8 angles. So the interior angle sum is 8 minus 2 times 180 divided by 8, because there's 8 sides of an octagon. So we have 6 times 180 over 8. Okay, we could do some reducing here. We could, so we could take a 2 out of this, that's 3, and a 2 out of that, that's 4. And let's see, can we get some out of this? Yes, we can. So we can take the 4 out of here, and that's a 40. So we take a 45. Okay, and 3 times 45 is 135 degrees. So each angle is 135 degrees. All right, so that's the interior angle of each. This is an individual angle. Individual interior angle. Okay, so the exterior angle is just 360 divided by 8. So that gives us 45 degrees. So that's going to be the the individual exterior angle. Okay, if each interior angle of a regular insided polygon is 156 degrees, find the value of n. So we have a regular polygon. We don't know what n is. We have n minus 2 times 180 divided by n, and it equals 156 degrees. So we're going to multiply by n on this side and multiply by n on this side, which cancels that out. So we have n minus 2. And let's distribute at the same time to save some time. So we have 180n minus 360 degrees equals 156n. Okay, so we subtract 180n from here and 180n from here. And we're going to come up here and continue writing. So that gives us negative 360 degrees, and this is going to give us 4, and then that's 24n right there. Okay, so 156 plus 24 gives us 180. Then we have divide by 24, and that's a negative, by the way. So we divide by a negative 24. So we have a positive amount of n because we can't have a negative number of sides. So 24 into 360. Well, it's got to be even, so let's use a dry erase calculator. Well, let's start guessing. So we have 24 into 360. Okay, so we know that there's at least 1 in here, so 24. Then we have 1, 2, 0, so that's got to be 5. And 5 times that is 120, so it is. So n has to be 15. Okay. So we have 15, so it's 15 sides. And there you have it. Okay, have a wonderful day. Bye-bye.